Hello all, a little presentation on question 3 related to the Ferris wheel. So to save some time in the video, I've drew it all out. You can see my little sketch of the Ferris wheel. So based on the first sentence, a Ferris wheel at amusement park reaches a maximum. So I've highlighted that in green at the top, 46 meters here. And then it says a minimum height of 1 meter, so I've highlighted that here. So there's the 1 meter from the ground up. It then says it takes 20 minutes for the wheel to make one full rotation. So if it was to go along this way in the anti-clockwise rotation, you could make it go clockwise rotation if you want. I've made it go anti-clockwise. You can see that 0 start, then if it's 10 at the maximum, that must mean that it's 5 at the quarter, 15 at the 3/4, and then back round to 20 minutes and back round to the start. So that's kind of the picture that I've set up. Now based on this information I can analyse quite a lot. It tells me that one cycle is 20 minutes, so if one cycle's 20 minutes, then that's the period. So I can find the value of b, which is 2 pi divided by the period, so 2 pi divided by 20. So that's nice and easy. The maximum is equal to 46 and the minimum is equal to 1. So from that I can work out my a value, which is the amplitude, which is 22.5. And I can work out d, the vertical shift, which is 46 plus 1 divided by 2, which is 23.5. So it then says write a sine function to model this. So the only thing I haven't got is the horizontal shift. Now the horizontal shift's a wee bit trickier, but I'll try to draw it graphically so you can kinda see what you have to do here. So the key thing is to draw this out. Once you've got the information, draw a sketch of the graph. So the minimum is 1, so it's not going to go below the x-axis. So I've got 1 here. It doesn't have to be to scale. And the maximum value is going to be 46, which is here. Now it tells me that the middle number between 46 and 41 is going to be our vertical shift, which is 23.5. So somewhere in the middle is 23.5, because that's the middle point of the numbers, which is also the vertical shift. So if I was to draw this, now think about it, what actually happens now is the Ferris wheel starts at 0 minutes. Remember, this is time, and this is the height in meters, and this is the time in minutes. So it starts at 1 meter, and then it goes all the way up to the maximum, then it comes all the way back down, and it goes all the way back up, and so on, all the way back down and all the way back up. Now I didn't really need to continue that because I just want one cycle. So what is one cycle here? Well, one cycle is when it starts at 1, it goes all the way 5 minutes. So this point here, because it's at 23.5, then it goes all the way to the maximum. And then at 15 minutes it comes to there, and then it comes back down here. So this point here is 20 minutes. So that's one whole cycle. But we know from our normal sine graph that it goes up, back down, and up. Alright? So if we think about this line here is where our sine graph should start. So that in essence is this line. So this line here is the old origin, if you think about it, to get the original sine function. So the original sine function starts at 0 from the middle, it goes all the way up, it comes back down to the line, goes all the way down to -1, and then back up. So if I was to imagine this and draw this again, how would it look? Well, let's just do it in yellow. Where would that starting point be? Well, that would be here. So it would go all the way up, all the way back down, and all the way up. You can see, so that reflects the original sine graph. All the way up, all the way back down, all the way up. So the horizontal shift reflects where your point on the original has started, which is here. So you don't start from the bottom on a sine graph, but we do start from the bottom here. So where is the horizontal shift? Well, it's from here to here. And at what point of that is that? Well, it's at 23.5. Well, let's look back up at our wheel. When is it 23.5? The middle point between 1 and 46 is 23.5. So that means that at 5 minutes, it's going to be 23.5. And at 15 minutes, it's also going to be at 23.5 because it goes round up to 23.5, up to 46, back down to 23.5, and then back down to 0. So I can see that the first horizontal phase shift is going to be 5 minutes. So now I've got my final function. So fx is equal to a, which is 22.5, sine bracket b, which is 2 pi over 20, bracket x minus 5, because it horizontal shift to the right 5, plus the vertical shift, which was 23.5. And the vertical shift is also the middle line to allow us to reflect where it shifted on the sine graph. Hopefully that makes sense to you all. If not, let me know. Fire more questions at me. Thanks.